Hi students, today in part B solved problems topic 10 is essay questions. What is 13th problem? A merchant has 105 liters of oil in one can and 90 liters of oil in another can. He wants to measure the oil with maximum capacity of measuring jar which can measure the oil without any oil remaining in any cans. What is the capacity of such jar? You see, this problem is application of Euclid's division lemma or algorithm. What are the topics we have in real numbers? Euclid's division lemma or algorithm, fundamental theorem of arithmetic, and rational and irrational numbers. Euclid's division lemma or algorithm is nothing but finding HCF. What is fundamental theorem of arithmetic? We can write a composite number as product of prime factors, rational and irrational numbers. In rational and irrational numbers, we have in short questions, we have showed how to show root 2 is an irrational number. When I was working in the school, I wrote this problem like this and asked the students what is the answer. First, they did not understand the problem. I have given a simple problem to them. A merchant has two cans. They filled with 100 liters oil and 50 liters oil. I asked what is the maximum capacity of the measuring jar which can measure the oil without oil remaining in the cans. One of the students answered 5 liters jar. Another student 10 liters jar. Another student 25 liters jar. Another student answered 50 liters jar. Which is correct? 5 liters jar is also correct. 5 liters means 5 is 20. 20. Here I will write 20 times. With the help of 5 liters jar, he can measure the oil 20 times. He can measure the oil 10 times. With the help of 10 liters jar, I will draw 10 liters jar so that you can understand. With the help of 10 liters jar, he measured 10 times and this can be measured 5 times. With the help of 25 liters jar, we can measure 4 times. We can measure 2 times. Another student answered 50 liters jar. 50 means 2 times he can measure. This 1 time he can measure. How can you identify 5, 10, 25? All are correct. How can you identify whether it is 5 or 10 or 50? How can you identify? With the help of HCF, we can find out the measuring jar directly. How? You take HCF 52 times 100. You are getting 0. From Euclid's division lemma, what is the, you are getting remainder as 0. Then what is HCF? HCF 50. You can take directly, you can write 50 liters jar is required to measure 100 liters can and 50 liters can. I explained this problem. They found HCF of 105 and 9. This problem depends on Euclid division lemma. Already I have told you many times. What is Euclid division lemma? If you divide a positive integer with another positive integer, you are getting quotient q and remainder r. It can be written as dividend is equal to divisor into quotient plus remainder. That remainder must be greater than or equal to 0, less than the divisor. To solve this problem, we have to find HCF of 105 and 90. How can you find out the HCF? If the remainder is 0 here, then what is HCF of A and B? HCF of A and B is B. We have to divide 105 with 90. We will divide 105 with 90 till the remainder is 0. 90 one time 5. You got 15 as the remainder. You are not getting remainder as 0. 105 can be written as 90 into divisor into quotient plus remainder. Divisor into quotient is 1 and remainder is 15. You are not getting remainder as 0. Again, you have to apply Euclid division lemma to 90 and 15. Again, you have to divide 90 with 15. 15 6 are 90. You are getting remainder as 0. As remainder is 0, HCF of 90 and 105 is 15. As remainder is not equal to 0, apply Euclid's division lemma to 90 and 15. 90 can be written as, say, 15 into 6. 6 plus 0. Remainder is 0. As remainder is 0, 15 is the HCF. As remainder is 0, 15 is HCF of 105 and 90. With the help of 15 liters jar, we can measure the oil in 105 liters can and also 90 liters can. You see, 15. How many times we can measure 105 liters can? We can, as 15 sevens are 105, 7 times we can measure 105 liters can, and 90 liters, 15 6 times we can, 6 times we can measure, because 15 6 are 90. Like that, 15 liters jar is required to measure the oil in both the cans. Therefore, 15 liters jar is required to measure the oil in 105 liters can and 90 liters can. Like that, Euclid division lemma or algorithm is useful in our daily life. Here I would like to tell one more thing to you. Now 105 liters can and 90 liters can. You can take 90 liters jar. With the help of 90 liters jar, you can measure this 90 liters can. You can measure one time. You can measure one time. But if you take 105 liters can, you see 105 is equal to 90 into 1 plus 15. 15 liters remains in the 105 liters can. With 90 liters jar, you can measure one time, but 15 liters of oil will remain in the 105 liters can. That's why we have to take 15 liters jar, because the HCF of 105 and 90 is 15. What is our 14th problem? You know, 13th problem is application of Euclid's division lemma. Euclid was Egypt mathematician. He lived 2300 years back. He belonged to 325 BC to 265 BC. This problem also application of Euclid's division lemma or algorithm. Using Euclid's division lemma, show that the cube of any positive integer is of the form 9m or 9m plus 1 or 9m plus 8 for some integer m. Let a be a positive integer. I am dividing a positive integer with 9 you have to take. Here divisor is 9. You see, divisor is 9. You take the divisor 9. I am dividing a positive integer a with 9. 9. You will get the quotient q and remainder is r. According to Euclid's division lemma, this remainder is greater than or equal to 0 and less than 9. This can be written as, here dividend is equal to divisor into quotient 9q plus remainder, or dividend is equal to divisor into quotient plus remainder. Here you write a is equal to 9q plus r. Cube of any positive integer. I have taken a positive integer a. Cube means cubing both sides. This can be written as a cube is equal to 9q plus r whole cube. Now a cube is equal to a plus b whole cube. What is a plus b whole cube? A cube plus b cube plus 3ab into a plus b. 9q whole cube plus r cube means a cube plus b cube plus 3ab. 3 into, what is a here? 9q. b means r plus 3ab into a plus b means 9q plus r. This can be written as 9 cube means you write 9 cube q cube plus r cube plus 9 3s are 27 qr plus 9q plus r. Now we have to take r is equal to 0. Substitute r is equal to 0 in this equation. A cube is equal to 9 cube q cube plus r is equal to 0 here. Substitute r is equal to 0 here. 27 qr. 27 into q into 0. 0 into 9 cube plus r, 0. You will get a cube is equal to 9 cube q cube. It can be written as a cube is equal to, a is a positive integer, a cube also a positive integer. This can be written as 9m. You write 9 into 9 square into q cube. Therefore, a cube is equal to 9 into, this can be written as, this is a positive integer, 81 q cube can be written as 9m, because 9 square into q cube is a positive integer. That's why a cube is equal to 9m. I wrote cube of any positive integer is of the form 9m. This is over. Next, 9m plus 1. Next, I will substitute r is equal to 1 in this equation so that you will get 9m plus 1. And I will substitute r is equal to 2 in this equation. You will get 9m plus 8. Substitute r is equal to 1 in this equation. A cube is equal to 9 cube into q cube and r cube. R is equal to 1 here. 1 cube plus 27 into q into 1 plus 9 cube plus 1. A cube is equal to 9 cube into q cube plus 27 q into 1, 27 q plus 9 q plus 1, and 1 q means you take here 1. This can be written as 9 into 9 square q cube plus 9 means 3q into 9q plus 1 plus 1. This can be written as 9 into 9 square means 81 q cube plus 3q into 9q 27 q square plus 3q into 1 3q plus 1. q is an integer. That's why sum of 81q cube plus 27q square plus 3q is also integer m. This can be written as 9 into, this is m, in integer m. I have to take some integer m. This is in the form of m plus 1. Like that, I wrote cube of any positive integer is of the form 9m plus 1 when you substituted r is equal to 1 in this equation. Next, if you take r is equal to 2, you will get 9m plus 8. What is our 15th problem? Prove that root 3 plus root 5 is an irrational number. Already in short questions, I have showed root 2 is an irrational number. I have already told you in proving root 2 is an irrational number, I have told you what is indirect method. Root 3 plus root 5, an irrational number, we know. But we have to assume this is a rational number. Let us assume to the contrary, root 3 plus root 5 is rational number. If we take root 3 plus root 5 rational, we will get a contradiction. Then we will say our assumption is false. Then what is true? Root 3 plus root 5 is an irrational number. That is indirect method. Root 3 plus root 5 is equal to a by b. A by b is a rational number. It's a rational number. A, b are co-primes. Now squaring both sides. You will get root 3 squaring both sides. Root 5 whole square is equal to a by b whole square. It is in the form of a plus b whole square. A square root 3 whole square plus b square root 5 whole square plus 2 into a into b means root 3 into root 5 is equal to a square by b square. Root 3 whole square means 3. Root 5 whole square means 5 plus 2 into root 3 into root 5. Root a into root b can be written as root ab means 2 root 3 5 is 15 is equal to a square by b square. Now 3 plus 5 8. 8 plus 2 root 15 is equal to a square by b square. Now I will do the problem here, rearranging the equation. Rearranging this equation, it can be written as 2 root 15 is equal to a square by b square minus plus 8 can be written as minus 8 here. This can be written as 2 root 15 is equal to, take LCM for this one, b square, you will get a square minus 8b square. This can be written as root 15 is equal to a square minus 8b square by 2b square. It is an irrational number, but this is a rational number. Root 15 is a irrational number. Irrational. And this is rational. This is a rational number and this is irrational. This is contradiction. Irrational number cannot become a rational number. This is contradiction. Our assumption is false. Then what is true? Then root 3 plus root 5 is an irrational number. Here a, b are integers. A, b belong to z, integers. Means and b is not equal to 0. You should understand this one. And a, b are co-primes. Means you take a is equal to 2 and b is equal to 3. Here You take A is equal to 2 and B is equal to 3 because A and B are co-primes. B should not be equal to 0. You take A is equal to 2 and B is equal to 3 because they are co-primes. Now substitute the values of A is equal to 2 and B is equal to 3 in this one. You will get a rational number. A square means 2 square means 4. 8 into B square. B square means 8 into B square means 9 by 2 into B square means 3 3 is 9. This is equal to 4 minus 72 by 18 is equal to minus 68 by 18. 2 3 2 3s are 2 4s are 8 2 9s are. You got minus 34 by 9 belong to integer. Minus 34 by 9 is a rational number, but this is irrational number. An irrational number cannot be equal to a rational number. We got contradiction and our assumption is false. And what is true? Given is true. What is given? Root 3 plus root 5 is an irrational number.